Alrighty, so we're going to do just a little bit of 3-5 today, just the beginning part of it. So 3-5 is looking at some more pieces of graphs. So we're going to go ahead and jump into our lesson goal for today. So our goal for today on slide 145, we're just going to determine whether functions have line symmetry and then finding that line symmetry. On our next video tomorrow, we'll talk about extrema, and then that's going to be the end of our unit. So we're going to be cutting off some of the stuff for 3-5, which is okay. We're going to still get most of it done though. Okay. So looking at slide 146, this is our important slide for today. So this is talking about line symmetry. When you think about symmetry, I want you to think about something being symmetrical or the same. So what happens on the left side and the right side of the graph has to be identical. A figure has line symmetry in the y-axis or some other vertical line. Okay, so we're always going to be looking at a line going up and down, okay, in order for our figure to have symmetry. So we're looking for a spot where we can cut our graph in half down the middle where the left side and the right side are the same. So for example, with this first one, the parabola, if I draw a dotted line here down the y-axis, that would cut my graph into two equal halves. So for example, this side would be the exact same as this side over here, okay, if I cut it in half. Now, when we're working with line symmetry, the line of symmetry is always going to be x. X equals some number, okay? That number is where it crosses the x-axis, okay? So in this example here, x is equal to 0, so my line of symmetry for this one would be x equals 0. Now, if I look at my other graph, again, it already gives you that dotted line here. So it's saying if you cut the graph there, that the left side, this side here, would be the exact same as the right side over here. Okay, so the blue and the red are identical to each other. Now, how I would get my line of symmetry, this point is at -1. So my line would be x equals -1. And that is our main idea for today. We're going to jump down to our next example on the next page. We're going to determine whether each function has line symmetry and explain. So with this graph, this is a linear graph because it makes a line. Now, something unique about linear graphs is they never have line symmetry. There's nowhere on my graph I can cut it where my left and my right side would be the same. So if we ever are working with a linear graph, there's never a time where it's the same on both the left and the right side. All right, if I look at my second example, hopefully you see that if we were to slice this graph right here, that would then give us this left side that I'm going to trace out in blue being the exact same as this right side that I'll trace out in red. And in order to identify the line of symmetry, we need to look at the point on the x-axis. So in this case, it's x equals 1.5. All right, another example here. If you ever have a U-shaped graph like so, you will always have a line of symmetry, and it's always here at the bottom or the top where the graph kind of starts to go in the other direction. So again, this would be our line of symmetry. The x value here is at -2 because I go left 2, so my line of symmetry is x equals -2. On this graph, there's nowhere where I can cut it. If I cut it here, then I fold it, that wouldn't be the same. If I cut it here and fold it, those wouldn't be the same because it would curve up and then curve down. So this one has no line symmetry. And that's okay to have no line symmetry. All right, I do like this question because it's bringing back stuff we've already talked about. We're looking at the y-intercepts of our functions from the graphs above. Remember, the y-intercept is the point where it crosses the y-axis, and how we write that is 0, comma, the y value where it crosses, okay? So if I look at graph 1 above here, my y-intercept, again, that's where it crosses the y-axis, which is our vertical axis. So here would be our y-intercept. It crosses at -1. So if I wanted to write that as a point, we need to write 0, comma, -1. Looking at the second graph here, the only place it crosses the y-axis is here at the origin, which is just 0, 0. So that's our only y-intercept, is at 0, 0. And then if I look here at the last one, or the last two, okay, my y-intercept on this third one is right about there. That's up 1, 2, 3, 4. So this one is at 0, comma 4. I'm just going to write it here so I don't have to keep sliding back and forth. And then the other one on this graph is at 2. So that's at 0, comma 2. If you want to fill those in on slide 150, you're more than welcome to, but I just wanted to put those here as well. All right, last one we're going to look at for today, and then we're going to have some practice. This is asking if it passes the line, if it has line symmetry. The answer, anytime it's this type of shape where it's in the shape of a V, your answer is always yes, okay? Similar to those U-shaped graphs, these V-shaped graphs are the same. Its line of symmetry is always the point where the graph like turns around and goes the other way, or that tip of the V. So here would be my line of symmetry. Again, we need to use that x value, so it's x equals 3 since we go right 3.